so that we can all refer to it later. Okay, you should be able to see my screen. So if somebody could just come up on the net and give me a holler that you can see my screen and hear me, that would be great.
Looks good.
All right, super. Thank you. All sorts of black screens out there. I guess everybody's recovering from spring break or something like that. All right, here's what we're going to do today. We're going to go over material requirements planning part 1. And looking ahead to the rest of this week, I'm sorry, I'm just trying to get the last folks in. Okay, looking ahead to later this week on Thursday, we'll have another Zoom session. And different from what we've done in the past, we will we'll pretty much have another working session, which is different than what we've done all semester. Usually we do some kind of U-Drive thing on Thursday, but due to the nature of this material, we probably need to spend another day or 2 days on it, building up to it. So that's what we'll do Thursday. And of course, also Thursday, a big day, the Way of the Warrior project is due no later than 7 p.m. on Canvas. So if you have any questions about that, that somebody else can't answer or that you want me to answer, please get hold of me sooner than later so we can get that cleared up. Seems like I had something else to say about that. I've seen a couple projects thus far. They both looked good. The big thing I can say just out of those two is please refer to the project standards before you begin writing. There's an outline and a format there for you. So I would appreciate if you did that. I'm not going to assign any Pearson this week because I want you to focus on doing your best for the Way of the Warrior project. At the earliest, I think I would assign, this is probably a little inaccurate, I might assign something due this Sunday. If I do, it'd be what we worked on from this week. But at the same time, I don't want to let what I put out before the break. I don't want too much time to pass before we get some reps in on that. And that's the 6-pack material. So between this Sunday and next, I will have something probably due this Sunday, and then probably next Sunday as well. So more to follow on that. I owe you some more concrete answers on that. Looking ahead to next week, this time next week, we'll go into statistical process control part 1. We'll have a Zoom on that. And then a week from today, actually 9 days from today, next Thursday, we'll do a WeDrive on that. So I'll put out a problem probably on Tuesday. You guys can work on it. And then on Thursday, we'll cover it together via Zoom. Okay. Before I go on, is there any questions on this slide right here in terms of kind of near-term targets? Okay, just to see a black screen staring back at me. All right, so here's what we're going to do today. There's my reminder to record. We're going to get into the first step of material requirements planning. So we'll talk about the overall purpose of that, talk about independent and dependent demand, bill of materials, and these other things. And this stuff can get complicated very quickly. So I think it's important just to ease into it, to understand why we do it, and it builds on itself. On the internal to your college side of things, for our supply chain warriors out there, Kylie, Tim, and Kyle, you all will do much more in depth reps with this Tim and Kyle next year, about this time next year, with Dr. Raj's class, and then Kylie, whenever that class comes for you. Dr. Raj is an expert in material requirements planning and the use of enterprise resource planning systems. And so you'll have a lot of fun with that. For the rest of you, it's still relevant and valuable, and potentially it's kind of a fun little problem to solve. It's like a puzzle. Okay, that's the way I look at it. But in terms of context, so lately, I don't know if it's just midlife crisis or being cooped up or dreaming about someday when all this stuff is over, but I've been looking at this motorcycle. Now, I have no business looking at this motorcycle. I've never driven a motorcycle in my life. I know it's very dangerous to do. Not that I'm afraid of dangerous things, but it's kind of unnecessary danger and so on and so forth. But wouldn't it be cool just to roll up to YCP every day on this thing and just get off and then spend the rest of the day with Warriors just rocking out? That would be really cool. But beyond that, let's think about this from an operation standpoint. So the first terms I want you to latch on to is the idea of independent and dependent demand. And all of this is going to snap right into what we've been doing with inventory. So if we produce these motorcycles, the motorcycle itself is independent. Okay. The motorcycle isn't dependent on anything. The dependent items, so the spokes, for example, and this wheel are dependent on how many motorcycles we're making. So it looks like there's about, I don't know, let's just say 10 spokes in that wheel. And we'll just assume there's 10 spokes in this wheel too. So that would make 20 spokes per motorcycle. You see where I'm going with this. The spokes are dependent on the motorcycle. So if we're making one motorcycle, we need 20 spokes. That's nice. If we're making 200 motorcycles, we need 20 times 200, and so on and so forth. And you can see that when we start talking about things and demand varying and inventory varying. So we might have some spokes in inventory and some spokes not in inventory. We might not be able to keep spokes in inventory. Some of the engine parts might get a little bit harder because they might come from certain parts of the country and we have longer lead times and so on and so forth. So you can see that very quickly the manufacturing of a simple motorcycle, this is actually one of the simpler designs, all of a sudden becomes quickly more complicated. So we need a way to manage all of that. And material requirements planning is a way to do that. Just look at this thing. I mean, it just looks so beautiful, kind of makes me want to cry. I mean, look at that. It's just, but anyway, beyond the beauty is just thinking about all the parts, the components that go into this motorcycle and how do we manage that? It doesn't stop with just motorcycles. We can extend this line of thinking to anything that has components like computers. I mean, all the different computers that go, or components that go into a computer, microchips, motherboards, microprocessors, wires, and so on and so forth. This computer that I'm talking to you on now is a 2010 computer. So it's getting ready to end its life cycle. In fact, I've been having kind of problems with it off and on. But again, back to you all, the main thing is thinking about how do we manage all of this dependent inventory as we produce whatever it is we're producing, whether it's motorcycles, computers. We could also extend this idea to food. We have cookies that are dependent on flour, sugar, chocolate chips. A certain amount goes into each cookie. We could take it to making pizza, although I have no idea that they're having that much fun. Anything, any kind of production where we have all these materials that go into the production and we need to manage them. Well, hopefully not this. So those are examples of what we're talking about and why we do it, because we need to manage all these different raw material inputs, all this dependent demand, so that we can produce the independent demand. Okay. So that's the big picture. And now let's go into some more specifics. Get my whiteboard set up. Okay. So the first thing to talk about is a thing called a bill of materials. All right. And we often call this a BOM, bill of materials. And hopefully today you have the ability to write with me, and we're going to do some Excel later too, and that you have the ability to build some stuff in Excel. Regardless, even if you don't, this video will be available for you as soon as well, not as soon as we get done, but later today, so that you can reference it. Okay, so the bill of materials, and this is essentially the recipe. I like to call it that. I don't know if other people call it that. But if you get online today and you say, well, I want to make some chocolate chip cookies, or I want to make dinner for my family, and so I'm going to make chicken breast or something like that. Personally, I hate making dinner, but who cares? So it's kind of like the recipe. You're going to get online and you're going to find all the things you need. Well, in production, we write it that way. We write it a little bit more refined, but not too much more refined. It'll look something like this. Let's say A is that overall thing that we want to make, that independent demand. And it might be a motorcycle, it might be a cookie, it might be, something else, a computer. And so this is just an example. To make A, in this example, we need two major things, components. We need B's and C's. Okay. And in this example, for every A, we need two B's. That might be like wheels for a motorcycle. For every motorcycle, we need two wheels. And for every A, we need three C's in this example. Okay. Now, some other simple terms. C is a child of A, and B is a child of A. That makes A a parent to B and a parent to C. Again, pretty simple. I'm just going to jot this over here. Parent-child relationships. Okay. We could also say that this is, I think, level 1 down. We could go multiple levels, and we will. All right. The main thing is that you can keep track of what goes where. Let's continue on with our example. So to make B, we need two children. We need D, and we need E. And in this example, D, we need two D's to make one B, and we need two E's to make one B. And over here on the other side, we need some things. We need E's, we need F's. And it just so happens to make one C, we need two E's, we need two F's. And you might say, well, that E is this E, so don't these cross over? No, because when that component is met with this component, it makes a C. Okay, and that component is different than B. Okay, so even though when we pull E out of this, it looks the same as that E, once it goes into this production process, It's not. So, and then we take this example farther down here with F, and we have G's, and we have D's. We need one G for every F, and we need two D's to make an F. Now, the interesting thing right here, we see, D is down here. Well, it's also over here, just like E is here and E is there. Okay. So again, the quick review before we go on. A is a parent to B and C. B is a parent to D and E. C is a parent to E and F. F is a parent to G and D. And I guess you could say, well, C is a grandparent and so on and so forth. Sure. Yeah. I mean, I wouldn't argue with that. So the next thing we want to do is say, okay, and what we're going to do today is what we call gross requirements planning. And the difference between excuse me, the difference between gross requirements planning and material requirements planning is that gross requirements planning, we're just going to identify the overall number of what we need. MRP, we're going to take into account where it's coming from. Okay, so today our focus is going to be here. I'm sorry, I've got somebody I'm trying to get in, and I don't know why. Here they go. Okay. So, what we're going to do now over here in this little box is figure out how many, if I'm building a certain amount of A's, how many B's I need, C's I need, and so on and so forth. Okay. So, I'm going to write in two overall colors. The color I'm going to use for, and this is just, you know, this is kind of a technique I developed for myself when I was learning this. This isn't mandatory. And that's why I said bring your colored pens, because that might help you keep all this stuff straight. But again, those are just tips. It's not required. Okay. So I'm going to use black for this side of the bomb. Okay. These dudes. And I'm going to use red for this side of the bomb. Okay. And hopefully this just doesn't become too crazy over here. So let me just section off my space. So the first question is, how many A's am I building? Okay. And I'll just keep it blue. So let's suppose in this example, I'm going to build 50 A's. Okay. So to build 50 A's, I'm just going to pull that 50 down and multiply that 50 by that 2. And I need 100 B's to build 50 A's. And that works out because B is not required anywhere else. Okay. Well, let's do C. So for C's, I'm going to need that 50 there. And I need 3 C's for every A. Whoa. Slow. Awesome. Sorry, a little bit of malfunction there. Okay, we're just going to drive on them and try to get rid of that. Sometimes my pen gets stuck. Sorry about that. All right. Here's my C. I need 3 of those. So my C here is that blue 50 I'm pulling down. And I'm just going to write it in red because I'm writing this right half in red, this side. Okay, super. Let's go to D's. And D I already know is going to be tricky because I got some D's over here and I got some D's over here. Let's do these D's first. For those D's, I'm going to pull down that B number. Okay, so that 100 there, I'm going to pull that 100 down and I'm going to multiply it by 2. And I'm going to do a little PEMDAS here. Okay, and then I'm going to go over to this side. Actually, I'm going to leave that alone for now because I haven't figured out F yet. So once I figure out F, I'm going to come back to this little spot right here. I'm just going to leave a little placeholder so I know to come back. Okay, so I have at least 200 there, and that's this side. Okay, let's go to E. Do E in red. Actually, let's do this E first. I know you're like, guys, going all over the place. Make it stop. Yeah, I know. All right. I'm going to do this side of E, and I'm going to pull that B down here. 100 times 2. I need 2 E's for every 1B. 100 times 2. And I know I have this right side. Well, I already know C, so I'm going to put 150 and pull that C down. So 150. And I need 2 E's for every C. So there we go. So I'm going to need 200 and then 300 for a total of 500 E's. Okay, now I can do F. I only have F on this side, so I don't really need to mess with the parentheses. F is dependent on C. I have 150 C's. So I'm pulling that 150 down, and I'm going to multiply by 2 because I need 2 F's for every 1 C. And that gives me 300. I didn't get G. Starting to run out of space. Let's just go ahead and finish off this D first. So because that's 300, I'm going to put that 300 there. And I'm going to multiply by that 2 because I need 2 D's for every F. There's my F. So I'm going to put my 2 in here. So that's 200 plus 600. I need 800 total D's. And then G's, just because I ran out. G's are dependent on F, so I'm going to take that 300. And I'm going to multiply. That's the amount of F's I need. I'm going to multiply times 1. Okay. So these are my gross requirements. To make 50 A's, I need 100 B's. I need 150 C's. I need 800 D's. I need 500 E's, 300 F's, 300 G's. All right. So that's great. That tells me how much I need. But what I also need to get into is when I need it. Okay. So what I'm going to do now is I'm going to take this. All right. I'm going to start a new screen and I'm going to show it over time. Okay. So the first thing we need to do when we think about this is let's reflect on our definition of lead time. So in the past, when we talked about EOQ, when we talked about lead time, we talked about the amount of time from when we put in an order to maybe a supplier to when we get that order back, when we get the receive. So we put in an order in, and we could say this is like order out or received. Okay. And we call this loop here lead time. Okay. Well, that still holds for this. But what we're going to do is expand that to also encompass the amount of time it takes to produce it. So from the time we say we need it, okay, and we could still say, hey, this is an order in to production, to manufacturing. But instead of a supplier, maybe it's a manufacturer. Sorry, got to let folks in. There we go. Okay. So again, lead time here is all of this. So from the time we say we need it, we could put an order into production and the time that it takes to produce it / manufacture. So in the center of this is this thing called lead time. Okay. So I want you to keep your mind broad that lead time isn't just with a supplier. Okay. It could be, if we're in a manufacturing business, it could be to ourselves. It could be to the operations section. And we say, hey, we need you to produce something. And they say, okay, the lead time is 4 days. That means from the time we tell them we need something, it takes them 4 days to produce it. And at the end of that 4 days, we have that item available. Okay. So there's a lot more robust term of lead time. I just want you to keep your mind broad as we're going into these concepts. And I have the world coming down around me with the landscaping guys and all this other crazy stuff happening. All right. So with that in mind, what we're going to do is we're going to take that bill of materials, we're going to turn it 90 degrees, and then we're going to visualize what kind of time is required to build A over time. So to do that, we need to take some lead times. Okay, and we need to know what our lead times are. So in this example, for A, we have a lead time of 1 week. All these are in weeks. For B, we have a lead time of 2 weeks. For C, we have a lead time of 1 week. For D, we have a lead time of 1 week. For E, we have a lead time of 2 weeks. F, a lead time of 3 weeks. And G, we have a lead time of 2 weeks. Okay, so again, this means that whatever way we get it, whether we put in an order to our supplier or we put an order to manufacturing or both, maybe a combination, it takes us 1 week from the time we put that order in to the time we receive it, and so on and so forth. So written like this doesn't really do us much good. We can't add these together or anything like that. The question is, how long does it take to make A? And so to get that answer, we're going to write our stuff a different way. We're going to begin with A at the top. But remember, we have that bomb, and we're just going to tilt it 90 degrees. Okay? So the way I'm writing this means from the time that we start building A to the time we finish, it takes 1 week. What do we need to start A? Well, we need B to be complete, and we need C to be complete. Okay? So the time we need to build B is 2 weeks. This is not to scale, obviously. There's probably better ways you could do this, maybe on some graph paper. So the time that we need to either build or receive B is 2 weeks. And the time that we need to build or receive C is 1 week. Okay. Now remember, these numbers here are different than my components required, and my parent-child relationship is still the same. Okay. But remember, before we had a number down here of 2. Okay, so this 2 right here is not the same 2 as this 2. All right, this 2 right here means that I need 2 B's for every 1 A. This 2 here means I need 2 weeks to complete B. Kind of like that movie, You Complete Me. Oh, terrible, terrible, terrible joke. Okay, so for now, I'm just leaving these subscript numbers off to keep things simple. All right, and what I'm trying to do here is depict from the time that A is required, I'm trying to reverse plan to see what this total time is. From the time that I say I want A produced to the time that it's complete. How much time is that? Okay, so let's continue on. Well, B can only begin once D and E are finished. And so it takes 1 week for D, and it takes 2 weeks for E. Okay, so we may start adding these up, 2 plus 2 plus 1. But we gotta remember about this whole piece back here, because it might be longer, and as it turns out, it is. So to make C, we have E and F. E takes 2 weeks, and F takes 3 weeks. And I'm just going to give myself a little more room down here. So F takes 3 weeks, and for F to begin, I've got to have G, and I've got to have D. D takes 1 week and G takes 2. So to determine the total time, I think I got something wrong somewhere. I think my C should be 3. 1, 3, 4. I think I wrote this wrong up here. Hmm. Well, I'm sticking with it. So based on this, I would have 1 week here, 1 week here, 1 week here, or 3 weeks there. That all checks out. And then I have 2 weeks here. So 5, 6, 7. Somehow that's not, I think my example is messed up. But for this construct right here, my total time is 7 weeks. Okay. From start to finish on A. Okay. So I take that longest time. These are done earlier than 7 weeks. They still got to be done. But I need stuff moving on G earliest because that takes the longest time. And I like this kind of way of viewing it. I think it beyond MRP, there's some commonality with project management and some other stuff that we're not necessarily going to get into in this class. Um, but if you're interested in that sort of thing, we can certainly talk about it. You'll probably study it in other classes. Critical path method is a big time project management thing. Um, so um, this is 7 weeks. So from here, what we want to do is go into Excel. I'm just wanting to check all my numbers because, all right. Actually, it turns out to be 8 weeks. I'm just wondering why I have a disconnect, but we'll figure it out here in Excel. So let's get rid of Walter White. All right. The last thing we're going to do today is we are going to identify gross material requirements planning for that item that we just did. So let's set up this way. Let's talk about our component. Okay. Of course, A is not really a component, but we'll just list it here anyway. We'll do lead time. Okay. And then what I'm going to do is this. So 2 dates we're going to talk about is first is the required date. And a required date is the day that we need to have the item so we can begin the next step. Okay. And I also like to say it's an end date. Okay. So either we're done with the entire project or we're done with that step and we can begin the next step. Okay. And I think this will make more sense as we go on. We also have another term, which is the release date. And I like to say that this is it. Again, we have to think holistically. When we say a release date, it's kind of like we're physically beginning to move something. We could order something, that's a release date. Um, we could start production on an item as a release date, but in both instances, the commonality is something starting to move. Either that order's on its way to us or we're starting production on building something. Okay, so I like to say that that's beginning something. And because we just did that plan, we know that this thing will take 7 weeks. Somehow my math is off. I know in my example it's 8 weeks, and we'll find out why my math is off. So what I'm going to do here is I'm just going to make some nice clean columns, and I'm going to go down and list these for all of my items. So with B, I have 2 weeks lead time. C, I have 1. D, I have 1 week lead time. E, I have 2 weeks lead time. F, I have 3 weeks lead time. And G, I have 2 weeks lead time. And a little bit redundant, but I'm just going to copy this all the way down. Just keep things nice and clean. All right, super. If I could just get Excel to cooperate. Okay, so what this is saying is that 8 weeks from now, based on my other plan, I'm going to need 50. That's my required date for those 50 A's. Okay, so the way that I like to do this is to go down and over. All right, so if I require 50 A's 8 weeks from now, I need to begin working on them 1 week prior to that because they have this 1 week lead time. Okay, so 1 week prior, movement needs to begin on those 50 A's. And this is where our gross requirements, it's important that we have those handy. Okay. And I don't have those values. I do, but I don't have them in a way to display them up on a screen. So hopefully you kept track of them with me. All right. I will go through them. Now, to begin those 50 A's, and I'm just going to highlight these two in green because that's the end goal right there.
Question.
Yes.
So you have 50 A's at the end of week 8, and you're starting those 50 at the beginning of week 7. So that would be a 2-week lead time.
Well, it isn't necessarily
So
it.
if you,
It's really just 1 week. I could begin them. I could have them ready on Wednesday and begin them on Wednesday.
okay.
So it's
I
not
just thought of
necessarily.
it as like the beginning of the 1 week and the end of the following week.
Yeah, I don't think that you have to think of it that way. I can see how that would be confusing. I would just say it begins in 1 week, and starts 1 week later. Does that make sense?
Yeah.
Okay. Super. Yeah. When I first started learning this and other things, it's kind of like, wait, it's really 2 weeks, but just think of it 1 week prior. So to begin those two A's, like we did in our couple other diagrams, we know we need B's and C's. So from here, we go down to B, and we need to be done with B's. So we need those 100 B's available to begin those 50s. So what I'm going to do for that left-hand side of the diagram is I'm going to do all that in black. And I'm going to do that. Well, I'm going to do it all in black. So for those B's, my lead time is 2 weeks. So I'm going to go down and over. I'm going to go down. I'm going to go over 1, over 2. And that's when I need those 100 to be released from wherever and to begin that movement. Okay, going back up here, I also need C's to begin A's. So I'm going to go down here to C. And I need 3 for every 1. So that's 150. And those C's I'm going to do in red because that's my right-hand side of my diagram. C's 1 week lead time. So I'm going to go down and over 1, and that would put me right here. Make that bold. Okay, so this is like not really the way I wanted to do this, but when you think about where we're at on our diagram, we started with A, and right now what I have up on the screen is B's and C's. So I have that first level done. Okay, so let's go back up to, we could start any way we wanted to. I'm going to continue with this side, the left side, as I call it, and so I'm going to go down and over. So when have those 100 done, I need to have D's and E's. So I'm going to go down here, and I need 2 D's for every B. So I need those 200 ready there. And those D's have a 1 week lead time. So I'm going to need them to start moving here. Okay, that takes care of those D's. And then E's, I'm going to need ready here. And I need 2 E's for every B. And that is 200. And I'm going to do that down and over. So down, it's a 2 week lead time here. So I'm going to go over 1, over 2. Okay. And at this point on my diagram, the left half is complete. So all this here is finished. All right, let's do the rest of my right half. So my right half continues with my C. So I go back to C, and for C, I know I'm going to need E and F on that day. So I'm going to go here to E. For every 1 C, I need 2 E's. So that's going to be 300. And I have a 2 week lead time on E's. So I'm going to go down and over 1, 2. I need those E's to start moving here. I also need Fs. So I'm going to go down here to F, and I need 2 Fs for every C. So that's going to be a 300. And for those Fs have a 3-week lead time. So I'm going to go down and over 1, 2, 3. Okay. And then I still have G's and D's because I have G's and D's dependent on F. So for these F's right here, I need G's to end there. Actually, it's out here. So for these F's here, I need G's there. And it's 1 for 1. So I need 300 G's available there. Not to be confused with $300,000. I'll take 300 G's. Anyway, 2-week lead time. 1, 2. And remember, I still have those D's that F is dependent on. So I need to go back up here, and I need 2 D's for every F. So that's going to be 600 that I need there. Wait a minute, that's in the wrong spot. I think. No, it's not. So I need those 600 there, and I need them to begin moving there. Okay. So one way I like to do is to check and make sure first that in each column or for each component, I can track start and stop. So just working top down, 50 items moving, released, 50 items required. 100, 100, 150, 150. When I get down to D, I should have 2 pairs, 600 and 600, super, 200 and 200, super. Here I have 300 and that 300, great. 200 and that 200, great. Here I have 300 and that 300, great. Here I have 300 and that 300, great. Okay, so that checks out. Another thing I like to do is just pick one of the 2 rows in between of the two and take the sum and make sure that adds up to my original gross requirement. So here I have 50, that checks out. Here I have 100, that checks out. Here I have 150, that checks out. Here I have 800 because I take that 6 plus that 2, that checks out. Here I have 500. I take that 2 plus that 3, that checks out. Here I have 300. That checks out. And here I have 300. That checks out. Oops. So I have all my gross requirements in place. And now I have an idea over time of when I have to start, what needs to be moving when, for what purpose. Okay, so I can walk this from, I like to walk it from right to left, okay, as opposed to left to right. I need the item here. So in order for that to happen there, I need these here. In order for these to happen here, I need these here. This isn't dependent on anything, so that ends. If I really wanted to, I guess I could gray that out. But again, those are added techniques. Here, and so on and so forth. Okay. Before I ask for questions, what this doesn't show me, and we're not going to get into today, is where the item is coming from the two big choices that we have. Okay. So the preview for Thursday is we can get the component item from one or two places. We could, and actually we could get it from three places if you really think about it. But we're going to talk about, well, we'll talk about those three. We could make the component item. We could have the component item in inventory, or we could order the component item to be restocked. Okay. So we could order it as is, we could pull it off the shelf, we have it on hand, or we could make it. Okay. Or we could do a combination of all three, that's what Thursday is going to look like. That's the difference between what we're doing today, gross requirements planning versus material requirements planning. Material requirements planning, we're going to add a few more rows, and we're going to deduct items from inventory and see where things are more specifically coming from. But I think this is really helpful to just get us into the process before getting really, really complicated with it. So at this point, I will stop and ask for your questions on any part of what I've covered today.
I think for earlier when you were figuring out why you were getting 8 weeks instead of 7 was because when you circled like the most weeks for each letter for the lead time, you didn't circle B was 2 weeks, you circled C, which was 1. So that would equal 8 because 2 is longer than 1.
You're talking about right here?
Yeah, that would be your 8 weeks.
Thank you, Myra.
Yep.
That's super. Everybody see that? So I guess you have to look across and see which is the longer. 3 trumps that. So good. I appreciate that. I think we all do. Okay. What else? Other questions, comments on any of this? 8. Okay, so what I would recommend, but not necessarily require, is, like I said, I'm going to make this video available shortly after we're done here today. But short of a specific problem, if you were not able, for whatever reason, to follow along today with all the calculations, I would start from scratch. So I would take not this diagram, but our initial diagram, and I would develop gross requirements from there. I would take these lead times, tip the diagram, do this like I did here. Hopefully not make the same mistake I did in terms of computing that right there, which we know is 8. And then I would see if I could reproduce the spreadsheet that I did on Excel, which I can make available to you later today as well. I'll hang that on Canvas. But short of a problem, you want to make sure you've got those foundations set before we step this up a notch on Thursday by adding a few more rows and saying, okay, well, if we have 10 of these on hand, how many more do we need and how do we trace that back? I think if you do have those foundations down by the time we begin on Thursday, Thursday will be that much more simple to you. And then you'll be able to ramp up to the material requirements, planning process, and then head into the weekend with a little practical exercise to do. Okay. So short of any questions, I will hang out until everybody clears. I'll make this video available for you later. If you have questions on the way of the Warrior Project, please get hold of me sooner than later. And with that, welcome back. I hope you all have a great week. Take care.